Okay, thanks for tuning in. We're going to talk about Chapter 11, just a brief summary of it, which deals with volume and three-dimensional figures and slices of three-dimensional figures. So we ought to start by naming these. So these two both have something in common. They are both called prisms. Now, we have to be particular. Those 3D figures look really different. This is a rectangular prism, and this one is a triangular prism. Now, a prism is a shape, or in other words, the shape of the base, and a prism means that the word is extruded or extended out so that the shape shows up on both the front and the back, and it's that volume inside. So that's what a prism is. It always has a rectangular, so you have both of these sides are rectangles. This one's got three faces that are rectangles, and this one's got four. And those are called prisms. This ball here is called a sphere. This one has square faces. It's got 6 of them, just like a die. So this is a cube. This looks like an ice cream cone, for sure. And this is a pyramid. Pyramids also come in different shapes depending on the base. So this one would be a square pyramid. And here we have a cylinder. Okay. So a cylinder is kind of like a prism, a little bit, but not really. So let's just go through these. So what type of 3D figure is this? Well, it's not a prism, because a triangular prism would look something like this, where the entire base is extruded or extended up. This would be a prism, but this one meets at a point, so this is a pyramid. And it's actually a triangular pyramid, because the base is a triangle. Triangular. Okay. And some of the, like a vertex or vertices, some edges, and some faces. There are 4 vertices. Some of them are like A and O. There's some edges too. Any edge that you see, CO, AB, those are both edges. They're line segments. And the faces of this triangular pyramid, they actually are all triangles. Not necessarily the same triangle, but we have triangle ABC and maybe triangle BCO is that front right face. Okay. So notice how this picture, it has a triangle as the base, but it's extended back. So it leaves behind these rectangles. This is an extrusion. So this is a prism, and it's a triangular prism. Notice how it matches a little bit the diagram I drew over here, and it matches this pretty well as well. How many vertices? Well, we got 1, 2, 3, 4, 5, 6 vertices. Edges, the 2 triangular bases have 3 edges. 1, 2, 3. 1, 2, 3. And when it is extended back, each vertex it creates an edge too. So 1, 2, 3. So I counted 9 edges here. Okay. And faces, let's erase our picture here. So the number of faces would just be counting. We have this triangle here and the back triangle. Those are both faces. And then we have that rectangle, the base rectangle, and the slanted rectangle. So I counted 5 faces. Okay. I think in the answer key it may have had something different, but this is the correct answer. A cross section. We define that as the shape obtained by intersecting a plane and a solid. So this yellow thing down here is a plane, and the blue thing is a solid, and this plane cuts and intersects along this red line. So this would be an example of a vertical cross section, and it forms a triangle, because when you have a triangular prism like this, it's just a triangle extended back. So every vertical cross section, like this yellow plane, like the one created by the yellow plane, they're all triangles. Okay. So this could be a question. Would be, what is the vertical cross section of this solid? And what you have to think about is if you took a plane like this and you cut it vertically through this thing, we're interested in what this shape is here. Okay. So it looks like it's a rectangle. Okay, and that would be true. But if instead you took it's hard to draw. Oops. All right. It's hard to draw, but it's definitely a plane that comes in like this and goes behind. And we're interested of what kind of shape it makes. But we already kind of see that the base on the top is kind of already cut in that horizontal direction. So we should expect the cut in the middle to also have that same rectangular shape. Like, imagine if you set it on the side and you chopped it like you were chopping up vegetables. The sides of those solids that you get as cuts, they should all have that hexagon cross section. Okay. This one's a little bit tricky. One thing you want to note is that this is actually a cone, but it was cut in the middle. I believe this shape is called a frustrum, so I wouldn't expect to see this show up a ton, but it's a good one to look at. So if we had a vertical cut like this, maybe it only goes down to the base, and it goes through this. We're interested in what that makes. So the top is a line, the bottom is a line, but they don't have, like, the top radius and the bottom radius, the circles are different. So this actually like extends downwards like that, and this would be the cross section, which is actually in this shape, which we'll learn is something called a trapezoid. It's kind of like it's kind of like a triangle from the cone, but it got cut. And then horizontally is a little easier, because we just have to take a plane and cut it through like this, and we would imagine we would get some sort of circle. Because there's circles on the top, circles on the bottom, in the middle it should also be a circle. Okay. Definitely saw this question on the packet I gave you guys, what 3D solid is created by rotating the triangle around line M? That would be, again, taking this triangle, rotating it like that, and makes a cone. Okay, remember this triangle is coming at you and then circling back. And this one you kind of have to envision, maybe draw a little bit and say, okay, this vertex is going to go in a circle like this, and so is this one, and it should have an edge here. So again, this is a cylinder when you rotate it. Okay. So now we have to actually apply what we've learned. So you will have formulas on the test. And I gave you guys, and if you didn't get one, let me know. I gave you guys the formula sheet that they give you. You don't need to memorize how to do this. I believe the formula they give you for, this is a prism, right? Because it's got a base, and it is just extended down. So the volume of a prism is whatever that base is times the height that you extended it down. Okay. It's almost like an accordion, like you had these two triangles here and you stretched one of them this way. So the base is a triangle like this. And we know the area of the base. So B is the area of base. It's capital B because it's not little b. Little b would be like a base length, whereas big B is area of the base. And it's a triangle, and the area of a triangle is 1/2 base times height. So the base looks like it's 4 or 3, whichever, and the height is the other. And but the big H, this H is this distance here, which is 6. So a formula you might say, just to keep all the letters straight, would be 1/2 length times width times height. If you want all the letters to be different. So this ends up being 6 times 6, which is 36 centimeters cubed. They'll make sure that you put units on it. So volume is cubic. Okay. This one also has the same kind of idea of like volume is base times height. Remember how I said cylinder is kind of like a prism because it does have like the same base and it's just extended down. But since it's a circle, the area B is pi r squared. So the volume of a cylinder is pi r squared h. It's just like the one we just did, except now instead of the area of a triangle, we use the area of a circle. Okay, which kind of makes sense, kind of gives a little bit more meaning to the formula. The radius is 3 and the height is 5. So typically I could see them asking you to put it in this form as an answer, but there's also a possibility that they want it as a decimal. So you have to read the directions, but if we use the pi button on our calculator, I got that the volume is this. They might also ask you to use, they might say like pi equals 3.14, or just they might say use the pi button, who knows. Typically they like to use this, but for the answers, the way I did the worksheet, I used the pi button on my calculator to get the decimal. Okay, but sometimes, like for me on my test, I would like you guys to, it's okay to stop here unless I give you more direction. This is a really neat answer. It's exact, whereas the decimal is like rounded, All right, so this one, I'm actually going to skip for the sake of time, but you do have to make 2 separate shapes here. You got that red solid, and you also have this rectangular prism down here. And you have to figure out what all the dimensions are of that, but the volume is going to be the volume of that uh, purple box plus the half cylinder. But for the sake of time, I'm not going to do this one. You can refer to the key if you want to see the answer to that. It's also more of a challenge question. So I want you guys to try that and look at the key if you'd like. But that's a tough question, I think, to see on a test too. Plus, I want to get to these other ones. So now we have a cube, a 6 by 6 by 6 cube, and we have a cylinder that's cut from it. And you want to find the volume of the remaining solid. So it's a subtraction here. So you have the volume of the cube, and then we take away the volume of the cylinder inside of it. And a cube is just like a box. If you want to find volume, you just multiply the three sides together. So this should be, you can write side cubed, and then we already know the cylinder has this formula. Okay, so the cube is going to be 6 cubed. That's the volume of it. And then the radius, they give us that this is 5. So the radius should be half of that, because that's the diameter, 5. The height of the cylinder, they don't show it, but it's going to go through the whole cube. So the height should be 6. So volume, this is 216 minus, and then 2.5 times 2.5 times 6 is 37.5 pi. So that's actually a good answer. I could definitely see them asking you to write that as a decimal. So when I use the pi button, I got this. So this many inches cubed, or 98 inches cubed. Okay, so we've already talked about prisms, really. Not pyramids yet, but for the volume of a prism, it's all you got to do is just do length times width times height. If it's rectangular like this one, but we also know that the prism has the formula just base times height. It just happens, so this might be the base, B, length times width. It's not always a rectangle. It could be a triangle, it could be a hexagon, right? So whatever that base is, it depends, it's just the area formula of that base. So you could have that, or maybe you have that the base is like 1/2 length times width, a triangle, or maybe the base is something more complicated and you have to find out how to do that. So it could be area of just any shape. Okay. And the same kind of goes with the pyramid. I think the pyramids that you will deal with will almost always be either triangular pyramids or most commonly square pyramids. So for this figure they have here, it's still length times width times height, but you take 1/3 of it. Okay. And for cylinders and cones, it actually has a similar story. It's just, we just talked about why it's this, and the cone, no matter if it's a slanted cone or a perfectly centered cone like this one, it's just 1/3 of the cylinder. Okay. All right. So volume of this cone, it has this formula. Wait, hold on. Yep. Pi r squared h. You'll be given that formula. It'll tell you that that's the formula for a cone. So the radius is going to be this length, which is 15. And the height is 25. So if you multiply all of that together and leave the pi in there, you get 1,875 pi feet cubed. And as a decimal, it's about this many feet cubed, rounded. Okay, so that's the formula for a cone. And this one's interesting because the formula has it where this is the height. And notice how they don't label this. This is the height. They give you the slant height, right? So the slant height is the height if you slide down one of the sides of the pyramid. The height, the true height, is from the top of the pyramid to the base. So it should be smaller to take a shorter amount of time to get down to the base. So the first thing we have to actually do here is come up with a way to solve for h, because the slant height doesn't really do us any good. So we kind of already see a triangle in there forming, where this is the slant height, this is the height we want, and the whole base is 8. It's an 8 by 8. So I believe this should be 4, because it's just from the center to the edge, which should be a distance of 4. And because I know the Pythagorean theorem works for right triangles, I can perform the Pythagorean theorem and solve for h. So when I did this, I got that h was the square root of 65. You can round that if you want. I'm just going to leave it as the square root of 65 until the end. But now we have that the volume is length times width times height, 1/3 of it. Now this is for a pyramid that has a square base. Okay. So the lengths of the length and width of the base is 8, and the height is the square root of 65. Okay, which that means that the volume, I did this out earlier. If you type all that in, you should get this. But that's what I got, at least. Okay. Kind of a tough one. So the volume for a sphere is 4/3 pi r cubed. Okay. That one's a little harder to reason why that's the case. But that is what it turns out to be if we had more time to maybe prove why that's true. So all you got to do for a sphere, it's actually pretty easy because you only have one thing that you're going to plug in for. So you just have to find out the radius. That's it. So this is 7.5. So I just put 7.5 in there. Okay. So if we do 7.5 times 7.5 times 7.5, and then that's really large, wow. And then times that by 4 and divide that by 3. I'm gonna verify this for you. Looks like I got a different answer before I did this in the video. 1 second. Yeah, okay, that looks good. All right. So if we have that and it asks, hey, what's the decimal for that? You would just need to multiply it by pi, and this is inches cubed, so you would get this. Okay? And I guess that's it. Let me just search through here if there's anything else I wanted to say. I think you guys might be okay with these. This one's a little tricky, but it is a prism, which means that the volume is the area of the base times the height. So you actually need to find out what the area of this is. And whatever that is, it's B. So you might decide, hey, let's split this in a few different parts. So the area of the base might be B1 plus B2. And for me, what I did is I said, okay, we have this part and we have this part. And I know that the area of the bottom part is 6 times 2. And the area of this chunk here, like the back of the seat, looks like it's just 6, because this is 2 and this is 3, and this doesn't really matter, and this is 6 and this is 2. So yeah, so the base is actually just 18. Okay, let's double check. That's what I got earlier. 10 plus 18. Yep. And then you just have to then say, okay, that's the area of the base, and the height is 8, because that's this distance here. That was kind of a tricky one, but it's still base times height, where base, capital B, is area. Okay? All right, thanks.